we present social diffusion. Our goal is to anticipate motion of multiple humans who interact in a social setting. Our method takes as input motion of multiple people and then forecasts their motion and social interactions. Forecasting social interactions is challenging for two reasons. First, social interactions tend to last tens of seconds or even longer, much longer than the prediction of most existing motion anticipation models. And second, social interactions consist of interdependent motion, which requires modeling the relationships among all individuals. For example, in conversational turn-taking, a person's turn to talk highly depends on the start and end of the others speaking. We utilize a diffusion model as we can easily reformulate it as an in-painting task for human motion forecasting, where we write the scene input motion over the diffusion signal at each backward diffusion step. For each person, we utilize a causal convolutional encoder E and decoder D to produce the denoise signal. To pass information between persons in the scene, we utilize a social aggregation function gamma, which combines the bottleneck layers H for each person. In our paper, we explore two aggregation functions, averaging over all the individuals in the scene and using multi-headed attention. We ignore the aggregation function for the ablation. In our experiments, we use the Hageling dataset, which contains triadic human interactions between two sellers and one buyer. The roles of seller and buyer remain fixed for this sequence, and the two sellers try to convince the buyer to buy their product. The dataset contains strong and well-defined social interactions, which makes it ideal for evaluating social interaction forecasting. For example, people generally respect the social rule of letting one person finish talking before taking turn in talking themselves. We now present results of our model on the test sequence of the Hageling dataset. Blue-red skeletons represent the ground truth input motion, and green-yellow skeletons represent our method prediction. Note that this is just one generation of plausible future motion, and that our model can simply produce any number of future sequences. Note that people take turns speaking and do not talk over each other, and that the motion remains realistic even after a very long time horizon. We now present results on challenging sequences of the SIMU MRT dataset. Thank you very much for your attention.